Multiplying probabilities. So in the last section, we talked about adding probabilities, and specifically when we are adding probabilities, it's because the question has asked us to find the probability of event A or event B. And that key word is or, and we would add the two probabilities together. The transition now to multiplying probabilities has to do with finding an event A and event B occurring. So once we do that, we have a multiplication sign. So the first thing we want to do is read the question and identify what the events are. A card is drawn from a standard deck of 52 cards. A spinner with 4 equal sections of different colors is spun. What is the probability of a jack and landing on a red? So there's our key word, and, which tells us that we're going to be doing a multiplication. So I'm going to find the probability. My first event is a jack. Oops, jack. And landing on a red. So we're just going to split up the two probabilities. What's the probability of a jack? And, so there's my multiplication, the probability of a red. So I break it down. How many jacks do we have in a standard deck of 52 cards? Well, there's 4 suits, and each one has a jack. So 4 over a total of 52 cards. Then we have our multiplication. Spinning a red, well, they tell us that there's 4 equal sections. So we have 1/4. There's one way we can spin a red out of the 4 sections. Then I'm just going to cross cancel. So I'm left with 1 over 52. And that's the probability of a jack and a red. The next question. On the last day of a grading period, 3 students with the highest average get to pick a prize from a bag containing 4 pairs of sunglasses, 5 keychains, and 6 air fresheners. What is the probability that the first student draws a pair of glasses and the second student draws a air freshener and the third student draws a keychain? Now, this is what we call a dependent probability. And the reason it's dependent is because we look at the probability of event A. And event A is that the first student draws sunglasses. Sunglasses. And the second student draws a air freshener. And the third student draws a keychain. So look what happens. We have the probability of the sunglasses times the probability of the air freshener times the probability of the keychain. Now the reason why this is dependent is because the total, or the sample space, is changing after each prize is drawn from the bag. So we have one bag, so here's the bag, and there's all the goodies inside of it. So the first one is the probability of the sunglasses. So we have 4 sunglasses. So there's 4 ways we can choose a pair of sunglasses. But the bag contains the sunglasses, the keychains, and the air freshener. So if we add those up, 4, 5, and 6, that's a total of 15 items. So our sample space is 15. Once the sunglasses are chosen, the student isn't putting the sunglasses back in the bag. He's keeping them because they're a prize. So that means that when the next student goes to actually draw, there's only 14 items left. So we have keychains and, air fresheners. There's 6 air fresheners. So there's 6 ways to choose, and there's 14 items in total. Now, we have a keychain. Well, there are 5 keychains, and there's now only 13 items. So the reason why this is dependent is because that sample space is changing, and it's changing based on the fact that some other event already occurred. Now we're just going to multiply the numerator and multiply the denominator together and simplify, and we get 4 over 91. The next question has to do with something called conditional probability, and that means that we're finding the probability that a second event, or event B is how we typically identify it, has occurred given that another event has already occurred. So we have a first event that's happening, and then it's the probability that the second event is happening based on the fact that the first one did. So here's a problem. We have a bag of 8 pencils that are red, 6 that are yellow, and 5 that are purple. 2 pencils are drawn one at a time and not replaced. What is the probability that a second pencil is purple given that the first pencil is red? So we're saying that event A, or the first event, is drawing a red pencil, and event B is drawing a purple, but only given that red was drawn first. So we're saying that we're trying to find the probability of a red and a purple. So this so far looks similar. So we're going to find the probability of red, and so multiplication, the probability, so this is where it changes a little bit, of purple given, this line means given, that red has already been chosen. So we're going to break down, although it's a little bit different, the formula, it's kind of just an idea of another dependent, what we just looked at earlier, but we're identifying it as conditional probability. So the first, we start the same, the probability of red. So we have red, 8 over the total number of pencils. So we add up 8, 6, and 5, and that's going to give us 19. Now, the probability of purple, given that we already found red. Well, how many total purple are there? 5. And how many are left over? So we had 19. One of the reds has been taken out. But we still have a bag that contains 19 items. One has been taken out. It's just been an actual red one. So that means that we still just have 18 left over. So basically when we're saying what is the probability that the second is purple given that the first is red, that's this probability right here. So we're not trying to find in this question the probability of red and purple. I just wrote it this way because this is what you're familiar with. We do our event A and our event B. Then we divide it up into what's event A, what's event B. Well, event B is the fact that we drew a purple, so 5 out of 18. This is not any different than what we did in the previous 2 questions. Please note that. I'm just starting to show you a different way to write it, and we identify it as conditional probability. So here's a little formula for conditional probability based on what we just did. We had, remember, red here, purple, red, then we had purple given red. You can rearrange this formula depending on what the question's asking. A lot of the times the question's saying, hey, find the probability of the purple given the red, or find the probability of the event B given event A. So what we can do is just think of this as an algebraic equation, and we can divide both sides by the probability of A. So a lot of the times when we're looking at conditional probability, this is actually the formula that you're going to use. The probability of event A and B occurring over the probability of the first event. So really what we're doing is we're just changing that sample space to be a lot smaller. So if we're finding the probability that an event has happened given that another one has already occurred, it's really finding the probability of the two together over the probability of the first one. So here's an example. Example 4. we have a table that shows the number of varsity and junior athletes, and there is a table that's given to us. Find the probability that a student is a varsity athlete given that he or she is a junior. So what comes after the given is event A. So the probability of event A, is that they're a junior. And then we want to find the probability of B given A. So that's really the probability that they are varsity and a junior over the probability that they're a junior. So what we're saying is that anything that comes after the given is our new sample space. So we're saying, what is the probability that they're a varsity player given that they're a junior? So varsity junior given that they're a junior. So the sample space is smaller. So we're going to look at our table. So we're looking at varsity and junior. So here's our table. Here's varsity. Here's junior. The number of people who are varsity and junior is 36. So our numerator is going to be 36. Our denominator is going to be the probability of being a junior. So how many total juniors are there? We add 36 and 276, and that is 312. And I'm just going to go up here. So the probability that the person is a junior, the person is varsity, given that they're a junior, is 36 over 312, which works out to be 0.115 or 11.5%. For the next one, find the probability that a student is a junior varsity athlete given that he or she is a senior. So event A is the senior and event B is the junior varsity. So our equation is the probability of B given A over the probability of A and B over A. So A and B, junior varsity and a senior. So junior varsity, junior varsity and a senior is right there. We get 257 over A is the senior, so the senior class we add 51, we get 308. We divide that, we get 0.834, which is 83.4. So what you want to do is identify what's the first and the second event, A and B, and then you're just subbing them into the equation.